Hello friends, welcome to the series of lectures of Mathematics 1. Myself Hardik Patel from LJ Institute of Engineering and Technology. Today's topic is a beta gamma function. Now first session we are going to start with a gamma function and its properties. Now first of all, gamma function. The gamma function of any number n is denoted by gamma n. This symbol is a notation of gamma. Okay, so and it is defined by the convergent improper integral from 0 to infinity e raised to minus x raised to n minus 1 dx. Now this is an improper integration of type 1. Okay, so which depends on the parameter n. This integration is depending on the parameter n. Thus, your gamma function is defined as gamma n is equal to integration from 0 to infinity e raised to minus x into x raised to n minus 1 dx, where n is greater than 0. See, here we have written n is greater than 0, but it is not necessary. You can define the gamma function for any non-zero, non-positive integer, non-negative integer. Okay, that means it must not be 0 or negative integer. Other than that, for any value of real number, you can find out the gamma function. Now, properties of gamma. First property is gamma n is equal to twice integration 0 to infinity e raised to minus x square into x raised to 2n minus 1 dx. So, we are starting with the definition of gamma. Now, definition of gamma is gamma n is equal to integration 0 to infinity e raised to minus x raised to n minus 1 dx. Correct? So, here instead of x, we required x square. So, we are starting with x is equal to t square. And that will give you dx is equal to 2t dt. Now, when x is equal to 0, then t is equal to 0. And x tends to infinite, then t tends to infinite. Correct? So, if you are going to put these all values in integration, then integration is going to be from 0 to infinity e raised to minus t square into t square raised to n minus 1 into dx will be replaced with 2t dt. So, simplifying 2 is going to be common out. Integration from 0 to infinity e raised to minus t square. This will be a t raised to 2n minus 2 into t dt. Now, simplify this term. So, that will give you 2 into integration 0 to infinity e raised to minus t square into t raised to 2n minus 1 dt. Replace t by x. That will give you gamma n is equal to twice 0 to infinity e raised to minus x square into x raised to 2n minus 1 dx. Okay. So, this proves your first property. Now, second property, prove that gamma of n plus 1 is equal to n into gamma n. So, we are starting with a definition. Gamma n is equal to integration from 0 to infinity e raised to minus x into x raised to n minus 1 dx. Replace n by n plus 1. That will give you gamma of n plus 1 is equal to integration from 0 to infinity e raised to minus x into x raised to n dx. Correct? So, if you are going to integrate, then integrate it by integration by parts. So, this will be u and this will be a v. U as it is, integration of v is e raised to minus x upon minus 1. Limit is from 0 to infinity minus integration derivative of x raised to n is n into x raised to n minus 1, and this integration e raised to minus x upon minus 1 as it is, and limit is from 0 to infinity dx. This is simple integration by parts. Now, if you are going to put the limit, then e raised to minus infinity will be 0, minus if you are going to substitute 0, then 0 into 1, that will be 0. So, this term is going to be 0. Here n and minus common out, so you will have plus n integration 0 to infinity e raised to minus x into x raised to n minus 1 dx. Correct? So, this is nothing but, see, this is your definition of a gamma function. So, this will give you gamma of n plus 1 is equal to n into gamma n. Done? Now, this formula is known as a recurrence relation or the reduction formula for the gamma function. If we are going with a property 2, then we have gamma of 1 is equal to integration 0 to infinity e raised to minus x raised to n minus 1 dx. So if you are replacing n by 1, so this is going to be 1, and you will have integration of e raised to minus x dx. That will be e raised to minus x upon minus 1. So if you are going to substitute the limits, then e raised to minus infinity is 0, minus e raised to 0 is 1. So that will give you the answer 1. Okay, so gamma 1 has a value 1. And using this, we are going to prove that gamma n plus 1 has a value n factorial in the case of n is positive integer. Please remember, if n is positive integer, then only you can write down this in a form of factorial. Proof we are going to give, and we are going to give the proof using the property 2. So gamma of n plus 1 will be n into gamma n. Again, use the same property for gamma n, that will be n into n minus 1 into gamma n minus 1. If you are going to continue this way, then you will have n into n minus 1 into n minus 2 up to 1 into gamma 1. Now gamma 1 has a value 1, so if you are going to put it, then you will have n minus 1, n minus 2 up to 1, and that is nothing but it is your n factorial. Done? So this is the proof for a gamma of n plus 1, that will be a n factorial. Now example we have written is gamma 8, that means gamma of 7 plus 1. This, and it is, if you are going to use this property, that means it is a 7 factorial. Okay, so gamma 8 has a value 7 factorial. Same manner, if you are going to write gamma 4, then it will be a 3 factorial. Done? Now prove that, third property is prove that gamma n upon a raised to n is equal to integration from 0 to infinity e raised to minus ax x raised to n minus 1 dx, provided that a is greater than 0. Okay, by definition of gamma of n is integration 0 to infinity e raised to minus x x raised to n minus 1 dx. Correct? Now replace x by au, and that will give you dx is equal to a du. And if you are going to put this, then when x is 0, then u is 0. Correct? So x is 0, then u is 0. X tends to infinity, then u also going to be infinite. So the limits are remaining same from 0 to infinity e raised to minus au into au raised to n minus 1 into a du. If you are going to separate this, then you will have a raised to n minus 1, u raised to n minus 1. So a raised to n minus 1 into a, that will be a raised to n, common out, and the remaining terms you have integration 0 to infinity e raised to minus au into u raised to n minus 1 du. This a raised to n is going in numerator in opposite side, that will give you gamma n upon a raised to n is equal to e raised to ax into x raised to n minus 1 dx. Why? Here you can replace u by x, because you can put any variable, and if you are going to change the variable, then there is no change in the answer of integration for definite integrals. Now the last property we are going to prove is gamma 1 by 2 is equal to root pi. So we are starting with the definition of property of gamma. We are starting with the first property of gamma. Gamma n is equal to twice integration 0 to infinity e raised to minus x square into x raised to 2n minus 1 dx. So what we are going to put? We are going to put n is equal to 1 by 2. And that will give you gamma 1 by 2 is equal to twice integration 0 to infinity e raised to minus x square dx. See, 1 by 2 into 2, that will be 1 minus 1 0. So x raised to 0 will be 1. So same thing I am going to repeat with the new variable y. So gamma 1 by 2 will be twice integration 0 to infinity e raised to minus y square dy. Now multiplying this two, that will give gamma 1 by 2 whole square, that is gamma 1 by 2 into gamma 1 by 2. That means twice 0 to infinity e raised to minus x square dx into twice 0 to infinity e raised to minus y square dy. And that will be nothing but it is 4 times double integration 0 to infinity e raised to minus of x square plus y square dx dy. See, 2 into 2, 4, integration and integration, we are writing it in the form of double integration as, and dx e raised to common e raised to minus x square minus y square, so we have common out the minus, that will give e raised to minus of x square plus y square. Now this is not directly integrable, so what we are going to do, we are going to change into the polar form as we have done in double integration. That means we are going to put x is equal to r cos theta y is equal to r sine theta, and that will give you dx dy is equal to r dr d theta, dx dy is equal to r dr d theta, and x square plus y square is equal to r square. Now, the limits of x is 0 to infinite, limit of y is 0 to infinite. That means if we are going to start with a figure, then x is starting from 0 going to infinity, y is starting from 0 going to infinity. That means we are starting with a 0 point and it is going up to infinity. So, first quadrant is the area of integration. Now we are starting with the polar curve, then you have to draw one transverse line from 0 to the curve. But here there is no curve, so your r is going to be up to infinite, correct? So if you are going to put the limits of r, then it is going to be r is starting from 0 ending to infinity. And if you are going to start with a theta, then theta is going to be theta is equal to 0 to theta is equal to pi by 2. Okay. So now you have the limits of r is equal to 0 to r is equal to infinite, and theta is equal to 0 to theta is equal to pi by 2. This is the simple method which we have used, but if we are going to use the polar coordinate, then the simplest thing to find the limit is to draw the curve. Okay. That's why we are going to use this region to put the limits. So your double integration is now reducing in a form of 4 times 0 to pi by 2, 0 to infinity, e raised to minus r square into dx dy, x square plus y square is replaced with r square, and dx dy is replaced with r dr d theta. So here e raised to fx into f dash x, if we are going to adjust in that form, then the function is directly integrable. So multiply and divide with minus 2. So that will give minus 2 into integration 0 to pi by 2, integration 0 to infinity e raised to minus r square into 2r dr. Now first integration is with respect to r. So you will have e raised to minus r square. Integration of this term is e raised to minus r square. So you have minus 2 into the integration from 0 to pi by 2, e raised to minus r square 0 to infinity d theta. So put the limit. So e raised to minus infinity will be 0 and e raised to 0 will be 1. So you will have minus 1 common out, and d theta is an integration theta. Put the limit, that will give you the answer pi. That means gamma 1 by 2 whole square is equal to pi. So you will have gamma 1 by 2 is equal to under root of pi. And this we have to remember. This is the fourth property of gamma. Now we are going on to the example. Find the value of gamma 13 by 2. If you are going to start with a gamma, anything, then you have to use the property. We have written second number property that gamma of n plus 1 is equal to n into gamma n. So 13 by 2 can be written in a form of 11 by 2 plus 1. So gamma of 11 by 2 plus 1, that means gamma n plus 1 can be written in a form of n into gamma n. That means 11 by 2 into gamma 11 by 2. Again write down 11 by 2 in the form of 9 by 2 plus 1, and that will give you 11 by 2 into 9 by 2 so if you are going to continue in this that way, then you will have 11 by 2 into 9 by 2 into 7 by 2 into 5 by 2 into 3 by 2 into 1 by 2, and last you have gamma 1 by 2. We are going to reduce this gamma until your value of gamma is between 0 to 1. Whatever the term here you have in, that must be in between 0 to 1. We are going to reduce up to that term. And once you have in between 0 to 1, then we are going to stop. But still we are aware of gamma 1 by 2 is root pi. So we are going to put the value of gamma 1 by 2, that will be a root pi, and simplify this term, that will give you 10,395 divided by 64 into root pi. Okay. Now we are going to start with one another example. Evaluate integration 0 to infinity root x into e raised to minus cube root of x dx. Now see, there are two types. If you have e raised to minus something, then it is the example of gamma. Or you have ln x or ln 1 upon x. In either of case, that is also the example of gamma. If you have e raised to something, then we are going to this something is equal to u. And if you have a log, then in that case we are going to use log of 1 upon x is equal to t or u or something, whatever variable you have to assume. Please remember this thing. So here you have e raised to minus something. So we are going to solve this example. Then we are going to start with the supposition cube root of x is equal to t. And that will give x is equal to t cube. That will give you dx is equal to 3t square dt. Correct? Now the limits. When x is 0, then t is 0. And when x is infinite, then t is infinite. Correct? So if you are going to put the values here, then you will have integration 0 to infinity cube square root of t cube, because x is equal to t cube, into e raised to minus t into dx will be 3t square dt. Correct? Now if you are going to write down in a simple form, then you will have then you will have 3 into integration e raised to integration from 0 to infinity e raised to minus t into t raised to 7 by 2 dt. Correct? Because this will be a t raised to 3 by 2 plus 2, that will be a 7 by 2. Now we are going to write down this in a form of gamma. So e raised to minus x, x raised to n minus 1 dx. That means e raised to minus t into t raised to 9 by 2 minus 1 dt. Now this is your standard format of gamma. So this is going to be a gamma 9 by 2. So 3 into gamma 9 by 2. Simplify in the form of gamma. So this can be written in a form of 7 by 2 into 5 by 2 into 3 by 2 into 1 by 2 into gamma 1 by 2. Correct? And gamma 1 by 2 has a value root pi. And 3 is already there. So 3 into 7, 21 into 5, 105 into 3 upon 16 root pi. So if you are going to simplify, then you will have answer 315 divided by root pi. Correct? So this is the simplest thing you have to do. Secondly, evaluate the integration from 0 to 1 x upon under root of minus ln x dx. Now see, here you have ln x. So what we have to suppose is, whenever you have given ln x, in that case we are going to suppose ln 1 upon x is equal to t. That means minus ln x is equal to t, and that will give ln x is equal to minus t. That means x is equal to e raised to minus t. Correct? Now x is equal to e raised to minus t, that will give you dx is equal to minus e raised to minus t dt. Now see the limits. When x is 0, then if you are going to put 0, then 1 upon 0 will be infinity and log infinity will be infinity. Then t is infinite. So x is 0, then t is infinite. And x is 1, then you will have log 1. Then in that case t will be 0. So x is 1, then t will be 0. So your integration is now from infinity to, so if you are going to write your integration I, then it will be from infinity to 0. E raised to minus t, x will be e raised to minus t upon under root of t, because minus log x is a t, and dx will be minus e raised to minus t dt. Now use this minus to change this limit, and that will give integration from 0 to infinity e raised to minus t into e raised to minus t, that will be e raised to minus 2t, and this will be t raised to minus 1 by 2. So if I am going to write this in a form of gamma, then it is t raised to 1 by 2 minus 1. So this is your property 3 of gamma, e raised to ax into x raised to n minus 1 dx. So if you are going to use the property 3, then it will be a gamma n, that means gamma 1 by 2 divided by a raised to n, that means a is nothing but a is 2 here. So you will have gamma 1 by 2 upon 2 raised to 1 by 2. But gamma 1 by 2 has a value root pi. So root pi upon root 2, that will be a root of pi by 2. This is the answer of our integration. Now these are some examples which you have to do yourself. And if you have any query or any doubts regarding these topics, then please feel free to contact me. Thank you so much.